Hello, today we're going to be talking about perimeter, which is the distance around a shape. Now, I'm going to note that these are what we call straight units or linear units. So things like your units are going to be things like inches, centimeters, feet, yards, miles, whatever. There's no exponent on these. When we're talking about perimeter, we should talk about two different things. We're going to talk a little bit about formulas. So basically the equations that we can use to find a perimeter, and we'll also talk a little bit about strategy. And there's a couple different things that we'll need to know. Now, there's tons of different shapes, there's tons of different formulas. But remember, all of the formulas are based around the same concept, which is going to be it's the sum of all of your sides. Now, let's start with our most basic one, say a rectangle. And with a rectangle, I've got just, I've got four sides. I'll have length and width. And my parallel sides, of course, are equal. So length and width. Length is, now these two sides are going to be equal. These two sides are going to be equal. So when I do this, I can say, oh, this is going to be, when I add up all four of these sides, I'll have length. Well, I'll be adding my length in there twice, and I'll also be adding my width there twice. So my perimeter is going to be 2 times the length plus 2 times the width. We also have things like triangles. Now, a triangle, I've just got 3 different sides, sides A, B, and C, and our perimeter is just like I say, it's the sum of all the sides. So that will just be A plus B plus C. Last but not least, we've got a circle. And circles are a little bit different because because I only have one side. And when we're measuring, we're usually going to measure either the radius, which is the distance from the center to the outside, so the radius, or I could have the diameter, which is the distance all the way across measured through the center. Now, if I'm measuring, now with a circle, we don't use the word perimeter, we use the word circumference. Oops. And we've got a couple things here. My circumference can be either 2 times pi times the radius, or I could also say that I could also say that my circumference is equal to pi times the diameter. Now I'm going to note here that the diameter is just twice the radius. So essentially these are the same sort of thing anyway. Pi is pi is a special number. It's infinitely long, and and you can say it's approximately equal to 3.14. But trust me, this decimal will go on forever. Yeah, 159 and a lot of change. Most people will just simplify it to 3.14. Although also if you want to use a good approximation, another good approximation is 22 sevenths. Now, neither this is not exact, and of course 3.14 isn't exact either. Most of your circles you're going to be asked to do things like round. So these are your basic formulas. Next, let's talk about strategy. And there's two main strategies that you're going to run into. One is going to be what I will think of as groupings. And you're going to discover this works very well for things like irregular rectangular shapes. So say I've got something like, this, where I've got something that is literally, I could think of this as like two rectangles, or I could think of this as three kind of rectangles stuck together, whatever. But usually what you're going to find is that you've got, you'll be given some sort of length and some sort of width here, and then some other information about these other sides. Now, they're not always going to tell you all of the sides. Now, there's a couple things that we could do with this. If I were told that this is, say, 20 and this side is, say, 8, I could be told that this whole side here is, say, 16, and this side right here is 6. Now, if I wanted to, I could figure out what these other two sides are. But here is the strategy I prefer. Well, but actually both of these things use the same idea. I'm going to be guessing, or I can infer that these two sides would add up to be this length. Now with that, I could know that this side right here would be, let's call that side A. I could say that A is going to be equal to 16 minus the 6 right there. So I could say that this side right there is going to have a length of 10. I could do that. Whoops. I could just as easily infer that these two sides right here will add up to be the same length as this one. So I could say, oh, this side B, I could say B is going to be equal to, say, 20 minus that 8. So I could say that, oh, B is going to be 12, whatever units these are. But beyond that, I can, when I use this, that's one thing, but I'll also point out that when I do this, I'm still going to be adding 1/16 plus something else that will add up to be the same thing. So I could still, when I group these together and say, oh, this is 16 and these are 16, I could still, for my perimeter, say that, well, these are going to be equal to 2 times that 16. And because these two sides will also equal 20, why not just add another 20 instead? So I would say, oh, this is 20 plus 20 is, well, 2 times 20. When I do this, that allows me to do quicker calculations with fewer numbers. And that's going to that actually makes the calculation a little bit easier. So here I would have 32 plus 40. This entire perimeter would be 52, whatever units I'm using. So you can use grouping with a shape like this. And not always are things going to just total up the same way. I could have shapes where I have perhaps I could have something where I've got maybe a cutout. And this is a little bit different because with a shape like this, I'm not even going to put in any numbers here. I could say, oh, this is my length, this is my width. And I'm going to note that, yeah, these two sides are going to be the same. So whatever my perimeter is going to be, it would be, my perimeter would have, probably be consistent with my colors, my perimeter would use 2 times that length. And I'm also going to note that, yes, these three sides would add up to be my width. So I could say, oh, that's This is one width, that's another width. So I can say, oh, that's going to be my width. But you know what? I don't have all of my sides listed yet. I still have some additional things. This, whatever these two other sides are, I'll just call them S for sides. I can still add those into our formula. I can still do that. Now, there's more than one strategy that works with something like this. I'll also point out, so this is just some broad strategies that you can use to help categorize your, help you organize your data to help you find your perimeters a little easier. Other things, you're going to find some shapes that are composites of other shapes. And with that, we're going to talk about breaking apart some things. So you can also, when you're grouping things, you can also do things like split you split or subdivide, basically divide and conquer your shapes. So say we've got something that looks a little bit more like, oh, I don't know. I could say we've got something like this. This here, I could see that the top half of my shape here is, this is half of a circle. And then I have 1, 2, 3 different sides. So with that, I could, when I'm putting together my pieces, I could say, well, my perimeter, therefore, is going to be literally half of my circumference plus my 3 sides. And I know that my perimeter here, so here my perimeter is 1/2, and what I just call this side here X. And if these are the same shape, great. But whatever this is, that X is also going to equal that diameter. So I would have my half of my circumference, that would be 1/2 of pi times X, or the diameter. And then plus my 3 sides. And if these 3 sides are the same, that would be 3 times X. If these are different sides, I would just add them separately. So when you're doing this, you might find you need to divide up your shape and use pieces to come up with a formula to find your perimeter. All right, that's all I've got for right now, and we'll see you in the next video.